The derivatives of the 6 inverse trigonometric functions are also given in this section because the section deals with inverses and their derivatives. So they are formulas to be memorized. They're pretty easy to memorize because they're also related to each other. So the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. And then its cofunction, inverse, cosine inverse, is merely the the negation thereof, negative 1 on root 1 minus x squared. And this will actually be a property of all of the inverse trig cofunction derivatives, that they're always just negations of the other one. So tan inverse of x, its derivative turns out to be 1 over 1 plus x squared. So therefore, I can already predict that cotangent inverse derivative will be the negation thereof. So you really have to memorize 3 things and just realize the cofunction inverses will be the negation. So now we have cosecant inverse x prime is going to be negative 1 over magnitude x root x squared minus 1, and then secant will be the negation thereof, which really means it'll be a positive 1 above. So 1 over magnitude function root of x squared minus 1. So 6 new rules to be employed in tandem with everything else we've discussed so far. I'll do a small example here. Maybe something like tan inverse of, I don't know, make up something interesting. 1 minus x over 1 plus x, something like that. Okay. We'll find that derivative. There is something a little interesting about the derivatives of these inverse trig functions, and that unlike the original trig function derivatives, right, the derivative of sine is cos, the derivative of cos is negative sine, and so forth, for all the original 6, they are all new trig functions. The derivatives are all trig functions back again in some combination. But here, for the inverse trig functions, their derivatives are algebraic, right? They're just roots and powers and quotients and differences and sums. They're just all just algebraic expressions. So it's an odd fact that the inverse trig function derivatives are algebraic, but the original trig functions derivatives are all trig functions back again. Nevertheless, to complete this derivative swiftly, so the derivative of tan inverse is memorized fact. It's 1 over 1 plus x squared. Right there, 1 over 1 plus x squared. So again, we have composition going on. We've got this function, this radical function stuffed inside the tan inverse function. So therefore, that's the first thing the derivative encounters. So therefore, we have to take the derivative of the outer function tan inverse, which is 1 over 1 plus something squared. The something is the input. So in this case, it's going to be the full 1 minus x, 1 plus x radical going on here. That's being squared. And then to complete the chain rule, we've got to take the derivative of the inner function and multiply it onto this. So we will have the square root of 1 minus x on 1 plus x with a derivative on that still needing to be taken. So I have 1 over 1 plus the square of this radical will of course be the input itself. And And the derivative of this radical here, if I view it as a 1/2 power, the 1/2 power would come down. The inner function now is 1 minus x on 1 plus x, and the 1/2 power that was here, right, at least theoretically, is now a negative 1/2 due to the power rule. But we still need to multiply by the derivative of the inner function, 1 minus x on 1 plus x. So there's still one derivative left in this chain to take. So now we'll have 1 over 1 plus, just rewriting very quickly, 1 minus x over 1 plus x times a 1/2. I'm going to use up this negative right now and flip the ratio inside. So we'll get that done. And now take the derivative here with the quotient rule. So we'll have bottom times the derivative of the top. The derivative of the top is negative 1. Minus the top times the derivative of the bottom, which is just 1, so I don't need to write it, over bottom squared. All right, now it's just a matter of cleanup. 1 times negative 1 minus 1 is negative 2. Negative x plus x is 0. So this numerator is really just a negative 2 sitting here. So I'll keep that in mind. Also, I want to simplify this. So I need to multiply this 1 here by 1 plus x over 1 plus x. So we should get something like 1 over 1 plus x, 1 plus x plus 1 minus x, 1 plus x, times a 1/2. I'm going to distribute this 1/2 to both of these. So 1 plus x to the 1, it's a little bit longer than I expected, or 1 minus x to the 1/2. And then here we said this is a negative 2, if I recall, over 1 plus x quantity squared. Okay, to finish up, we'll have 1 plus 1 is 2, and x minus x is 0. So we'll have the reciprocal of 2 over 1 plus x, 1/2, 1 plus x to the 1/2, 1 minus x to the 1/2, negative 2 over 1 plus x quantity squared. This 2 will cancel with this 2, of course, leaving a negative 1 in that numerator. So now we have x plus 1 over 2, right, taking the reciprocal as it says here, and a lot of 1 plus x's to combine together. 1/2 minus x to the 1/2. That negative 1 I'm just going to pull out to the front here. There it is. And we still got a 1 plus x squared on the bottom. Okay, so let's we have x plus 1. Okay, so we got the first, and for the 1/2 power, that's the 3/2 power. I've got a power of 2 down here. So subtracting 3/2 from 2, I'll have a 1/2. So this should be negative 1 is all that's left. Okay, I wasn't anticipating that. Sorry to put that negative right back where I took it. But anyway, there's nothing left in the numerator except for this 1. So negative 1, we have a 2 down here. We have 1 minus x to the 1/2. And then we have the cancellation of all these leaves merely a 1/2 power on the 1 plus x as well in the denominator. Rewriting it with the radicals that it began with, I guess, is more appropriate. So I have negative 1 over 2. They both have a root, so I'll just put them inside the same 1. 1 minus x, 1 plus x. And there's our derivative using a inverse trig function rule.